The next type of point of concurrency is the in-center. Now this is the point of concurrency of the angle bisectors. Now if you remember from lesson 1, we learned that if you know that something's an angle bisector, then any point on it is going to be an equal distance from the sides of the angles. So the in-center is equidistant from the sides. So from P to Y, it's going to be equal from P to Q. It's going to equal from P to Z. So if you know it's on an angle bisector, it's equidistant from the sides. And the way I remember this, remember how the circumcenter was equidistant from the angles and made by the sides? This is made by the angles and equidistant from the sides. So that helps me to remember what it's made by and what it's an equal distance from. Now the last fact about an in-center is that it's the center of the inscribed circle. Now an inscribed circle is a circle that's drawn inside a polygon that only just barely touches each side at one exact point. So this circle, circle P, is going to be only touching side AB at one exact point right here, and then one exact point right here, and one point right here. It doesn't touch at anything more than just those one points. Okay, so it's inside the circle. It's the in-center, in the center of the inscribed circle. Okay, so let's take a look at an example about this. In this picture, they've told us that JV and KV are angle bisectors of triangle JKL. So we know that this right here, this JV is an angle bisector and KV is an angle bisector, meaning that V is the in-center. They want us to use that information to find these three measurements. So in part A, they said the distance from V to KL. Now notice that's the distance from the in-center to a side of the triangle. And remember, the in-center is equidistant from all the sides, meaning that I just need to find one of the distances to a side. They've given me that right here at 7.3. So this answer is 7.3. Next, they wanted me to find the measure of WJV. WJV is this angle right here. Now, they've already told me that JV is an angle bisector, meaning that if this is 19 right here, then this side has to also be 19 degrees. Now, the last one's the hard one. They wanted WKV. WKV is this angle right here, so we have a little work to do for this. What we're going to do is we're going to remember that all of the angles of a triangle add to 180. So notice, if this is 19 and this is 19, I would get 38 for that angle. I have 106 right here, and I can subtract to get the whole angle up here, but I only want half of that. So let me show you my work. So what I did is I added 19 plus 19 to get this whole angle down here. Then I added on the 106 degrees that I had in this angle over here. That got me 144. Then I did 180 minus 144, which is 36. So this total angle is 36. But they didn't want the total angle. They wanted this part of it. So I had to divide it in half. And my final answer is 18 degrees. And that's my answer for part C. Now you're going to try it. And check it out, number 3. They told you that QX and RX are angle bisectors of triangle PQR. That's this segment here and this segment here. What you need to find is the distance from X to PQ, and they wanted angle PQX. That's this angle right here. So see if you can figure it out, put it on a Google Doc with your classwork, and then press play to see example 4. Example 4 is the last example of our lesson. It says, for the next 4th of July, the towns of Ashton, Bradford, and Clearview will launch a fireworks display from a boat in the lake. Draw a sketch to show where the boat should be positioned so it is the same distance from all 3 towns, and justify your sketch. So you're actually going to put this on your classwork as well. Decide if we need to find the circumcenter or the incenter and tell me why. You don't have to draw this, but decide between circumcenter or incenter and then tell me why. Okay, so that's the last thing you need to do. Don't forget to submit your classwork and check for some homework.